Hi guys, here's section 5.2, example number 4. Notice we don't have fractions in this one. So my next step is to identify which one is hardest side, or most complex side, I guess I should say. This is the most complex side. And I'm going to look to see if I can factor anything out of there. Do these two terms have anything in common? Remember, we are ignoring this piece over here. So without that piece, looking at this term and this term, what do they have in common? They both have a cotangent, 1, and they both have a secant. So I'm going to factor out of this one cotangent and one secant. When I take those guys out of this term, I'm left with cosecant squared f, or squared theta. When I take away one of these cotangents, this becomes cotangent squared theta, and we get rid of this guy, so minus cotangent squared theta. We have an identity with both cotangent and cosecant in it. And so cosecant squared theta minus cotangent squared theta, so if I move this guy over, it's equal to 1. So this whole guy here is just 1. So I just have cotangent theta, secant theta times 1, which is cotangent theta, secant theta. And now we're going to try to simplify it. Remember, we're trying to get to cosecant theta. I don't have anything else to do here except for to put it into sines and cosines. So cotangent is cosine theta over sine theta. Secant theta is 1 over cosine theta. Unfortunately, something cancels out here. We're left with 1 over sine theta. That's going to be cosecant theta. All right, let's look at the U try. Again, we're going to do this one by factoring. So looking at these first two terms, here, between this guy and this guy, what do they have in common? See, they both have a tan squared x and a cosecant squared x. So that's what we'll factor out. Tan squared x, cosecant squared x. What we're left with over here is sine squared x. And in our second term, we just have cosine squared x. All right, our first Pythagorean identity says sine squared x plus cosine squared x is equal to 1. So this one's easy. This is times 1. And we're left with tangent squared x, cosecant squared x. Now we need to prove that tangent squared x, cosecant squared x is actually equal to secant squared x. So let's break it down to sines and cosines. We've got sine squared x over cosine squared x. That's our quotient identity for tangent squared x. Reciprocal of cosecant is 1 over sine squared x. Our sine squares will cancel out. I've got 1 over cosine. That's the reciprocal of secant. So this is secant squared x, which is where we were headed. All right, that's it for example number 4. I will come back with example number 5 after I get my daughter.